Alright, we're going to look at reasonable domain and range, and I think this is like page 10 of your notes. So if I look at number 1, it's just an equation, and it has arrows, meaning it's going to go up forever and right forever and down forever and left forever, and so that means my domain is all real numbers, and my range is all real numbers. But if I put this into a word problem, like number 2, a taxi ride costs an initial rate of $3, which is charged as soon as you get in the cab, plus $2 for each mile traveled. My function rule will be y equals $3 plus $2 x. And then my independent is my x, and it stands for number of miles. Right, $2 for each mile. Mile is your x. And the dependent is your output, your y value, which here is your total cost. And this domain and range would not be all real numbers, even though it has the same equation as number 1. The domain here, if I'm talking about miles, miles can't be a negative number. So my domain is anything greater than or equal to 0. That's all of your positive numbers. In my range, if I pay for 0 miles, but I called that cab, I still have to pay $3. So my range is y is greater than or equal to $3. Okay, number 3, same idea. A banquet hall charges $15 per person plus a $100 setup fee. The cost is a function of the number of people that attend. So my function rule is y equals $15 per person plus $100. My independent is my x, my input, and input here is per person, so your number of people. And my dependent is the output, the y value, and that's going to be your total cost. Because that's what this problem is talking about. The total cost is $15 per person plus $100. And so my domain, I got to think about reasonableness here. Up on number 2, we said greater than or equal to 0, which means I'm including decimals and fractions. And I can include those because I can have half of a mile. So this particular problem is continuous. Whereas if I'm on number 3, this problem is discrete. Because you can't have half of a person. You can't pay for half of a person. So you're going to pay for the number of people that show up. And so my domain, I wouldn't write it like this. I would say it could be, I could have 0 people, or 1, or 2, or 3, and so on. Just like my range has to match my domain. So my range is my total cost. If I have 0 people come, I still had to pay $100. And then if I have 1 person come, it's $100 plus 15. And 2 people would be $130, and 3 people would be $145, and so on. Okay. Number 4. 8-ball billiards charges $5 to rent a table plus $10 per hour to play of gameplay. Round it to the nearest whole number. So that means you're not paying for part of an hour. Even though hours is a continuous thing, in this situation we're paying for whole hours, which makes this function discrete. My function rule is y equals $5 to rent a table plus $10 per hour. So my independent, my x, is number of hours. And my dependent is my y, which is the total cost again. And so my domain, since it's discrete, has to be a list of possible options. So you could play for 0 hours, or 1, or 2, or 3. And I mean, at the end of the day, it's not going to go on forever because you're not going to stay there and play. But we don't know when they're going to stop, so we're just going to show that it's going to go on. In the range, if I get the table, if I ask to play, then I'm going to have to pay $5. And then if I change my mind, I don't think they're going to give me my money back, but there's $5 for 0 hours of play. Or if I play for 1 hour, then I'm going to add $10 to that, and add $10 for 2 hours, and $10 more for 3 hours, and so on. So it's thinking about what makes sense for the problem. Okay, number 5. The Western Hills High School Booster Club is going to donate $100 plus 1/3 of the money it raises to a charity. So if I were to write out this equation, I would say y equals, it's going to donate $100 plus 1/3 of the money raised to charity. Well, I don't know how much they're going to raise, so that's going to be my x. So that means my independent, my x, is the money raised. And my dependent is the total money donated. Okay. This particular function would be continuous because you can have half of $1, right? So the money is continuous. You can have part of $1. My domain would be anything that I raise, but it's not going to be all real numbers. I'm not going to have negative numbers, but I can say it's anything bigger than or equal to 0. Maybe we don't raise any money. So the domain is a set of all real numbers greater or equal to 0. In the range, if I don't raise any money, they are still going to donate $100. So y is greater than or equal to 100. So it's a set of all real numbers greater or equal to 100. Number 6. A small pepperoni pizza at Bill's Pizza contains 1,000 calories. Sam ate between 2 and 5 pizzas this week. If I were to make a function rule about that, y equals 1,000x, where x is the number of pizzas. Right? That's my independent. My dependent is the total number of calories. Now this one gave us stipulations. He ate between 2 and 5. Remember, pizzas is your x, so that's your domain. And discrete or continuous. And in this situation, I would say continuous because you can eat part of a pizza. You might only have one slice or maybe one bite of a slice, but you can eat part of it. So your domain is between 2 and 5 because that's how many he's eaten. So it's going to look like that, anything between 2 and 5. So that's, the domain is a set of real numbers from 2 to 5. And now I got to think about, well, if Sam eats 2 pizzas, that would be 2,000 calories. And if he eats 5 pizzas, that would be 5,000 calories. And range is y, and we just have to match it up. So I'm plugging 2 in for x, then I'm plugging 5 in for x. Those are my constraints. I'm between 2 and 5. And so the range is a set of real numbers from 2,000 to 5,000. Okay. Number 7, the total cost Avery spent on a sandwich and several bags of chips can be found using the function c equals 0.75x plus 4, where x is the number of chips she bought. She bought at least 2 bags, but not more than 7 bags of chips. So they gave us the function rule. They said c equals 0.75x plus 4. And she bought a sandwich and several bags of chips, which we don't know how many bags of chips she bought, which is why it says x is the number of chips she bought. So my independent is number of bags of chips. My dependent is the total cost. In this situation, it's discrete because you cannot buy part of a bag. You can eat part of a bag, but you can't buy part of a bag. You have to buy the whole thing. And so this domain, since it's discrete, is a list of numbers where we would say at least 2, meaning she bought at least 2, or she bought 3, or 4, or 5, but not more than 7, or 6, or 7. So the domain is a set of integers because we don't have any decimals from 2 to 7. And then in order to figure out how much money that is, you would plug 2, or we could even make a table here, 2, 3, 4, 5, 6, 7. And so this is your X, this is your Y. And I would just go to your calculator and you would type in 0.75 times 2. And if you type in 0.75 times 2 and then you add 4, you get 5.5. And really we don't need to know all these in-betweens. We do need to know the 7. So if you type in 0.75 times 7, and then you add 4, you get 9.25. So it's just plug and chug, plugging this number and this number in for X. So my range, and I take that back, I actually should figure out all of these because we need to list them. If she bought 2 bags of chips, it would be $5.50. And then you would keep adding 75 cents. So if we plug in all of these numbers, 3 bags of chips is $6.25. We're adding 75 more cents, so 4 bags of chips is $7. And then $7.75, and then $8.50. And so our range, we just list them all out. $5.50 and $6.25, $7.75, $8.50, $9.25.